go in 5, 4, 3, 2, 1. What's up, everyone? Welcome to Simulation. We are going to be talking about the future of food. We're going to be talking about biotechnology. We have with us today Jack Bobo. Thanks for coming on to the show.
Sure, I'm really excited to be here.
Really appreciate you coming on. You are the Chief Communications Officer at Intrexon and Senior Vice President. You've also, that's been 3 years.
Yes.
And also for 13 years, you're the Senior Advisor of Global Food Policy at the U.S. Department of State.
That's correct.
Which is pretty long time to spend doing global food advising.
Well, there was a lot happening in that 13 years.
Yeah, and we got to sustainably and nutritiously feed the world, and that's crucial.
It is, and the population is just continuing to grow.
Yep. And we were fortunately enough introduced by, how did we initially, I know RJ and then Intrexon.
I can't remember who our specific connection was.
Yeah, but we met in DC for the first time, right?
Well, you and I met here in San Francisco when I knocked on the door at the science comedy session that you guys were doing.
And that was on astrophysics.
That's right.
With exoplanets with Jesse Christensen. That's when we first met. And your son won an alien.
He did win an alien, which he now has in his room, in his bedroom at our house.
So that's when we first met, and then met again in DC when you were definitely teaching me a lot about biotech, and now we're here again. Awesome. And you're based in DC.
I am.
Okay, so this is intense. We're figuring out how to feed and sustainably, nutritiously the whole world. But Intrexon has a bigger, biotech everywhere goal. Let's maybe do some of that, and then we'll go into the future food stuff. So you guys are up to everything in biotech. I mean, we're talking food, we're talking health care, like things like oncology, things like just genetic engineering in general, things like eradication of mosquitoes, the browning enzyme in all the apples and food. This is very interesting stuff, so teach us about this.
Yeah, well, we are DNA.com, right? So we are the ultimate biotechnology company. And I often tell people, Intrexon, it's the coolest company you've never heard of, because we're working in health, energy, food, environment, pretty much every sector. Now, a lot of companies say biotechnology is a platform that we use, but when you look at what they do, it turns out, well, they're a healthcare company, or they're an agriculture company. But Intrexon is really unique in that we cut across all of those fields, and what we learn in one really helps us to advance in another.
Yep.
And so you mentioned in the health area, well, we have a couple of dozen partners that we're working with on human gene therapy and all sorts of products that are in cancer therapy, skin diseases, eye diseases, and we're helping other companies to bring these gene therapies to market. One of the things I think is cool is that we believe that every gene therapy in the world should come with an off switch. If there's a problem, you want to turn it off. If you cure the cancer, you want to turn it off. You don't want to be getting chemo for the rest of your life after it's gone. So that's the thing that Intrexon brings to a lot of those partnerships.
And this is so interesting to have these 22,000 human genes and be able to just turn on or off the expressions at will.
Right. So gene therapy is a very powerful technology, but it's also a very powerful technology. And if it works well, that's fantastic. But you're overproducing an enzyme that could have an impact on the body, and we're able to turn that off, and then we can turn it on 20%, 50%,
Wow.
75%,
Yeah.
and get it just right to dose the patient with gene therapy. And this isn't the drug, this is the therapy itself.
And how do we get into the cell and figure out how to do that?
Well, so there are different ways of doing gene therapy. A lot of the companies are using a viral approach, ours is a non-viral approach. And one of the benefits of that is that rather than having to send it out to a centralized facility that could take 30 days, we can transfect those cells right next to the patient, and within a couple of days we can actually reintroduce those into the patient. And so the idea is, one, that it's faster, we hope that it will be more cost effective, and you'll be able to get that benefit. And these are often terminally ill patients, and so speed and time is really of the essence.
And so right now the technologies are you can take the cell out, reprogram, put back in, or you can deliver nanoparticles into the cell and have it changed like CRISPR.
Right.
Technology.
It's somewhat similar. You're using a different kind of gene editing tool in order to do this. But ultimately, we're introducing those changes into the cell, but then they turn off, and so you don't have to worry about it once you've achieved your goal.
This is everything from eradication of disease to augmentations in humans. This is exciting.
Well, we're focused on addressing diseases that are out there. There are plenty of challenges that we face right now.
Yep. Okay, and then so that's like this health, and then you said energy and agriculture, and what else you said was interesting was that what you're learning across sectors is applicable to each other because it's biology, it's the code of life.
Right. So one of the things we're doing is we produce the genetically engineered mosquitoes that are going after the mosquitoes that carry Zika, dengue, chikungunya, yellow fever, things like that, the Aedes aegypti mosquito.
And this kills millions of people a year, right?
Well, so Aedes aegypti impacts about 400 million people a year, but not as many people are dying from it. More people die from malaria than from dengue or for these other diseases. But they're obviously traumatic and dramatic impact. And as we saw with Zika, obviously you had thousands of children that were born with microcephaly and other disabilities as a result of that. And so if we can eliminate the mosquito, we have an opportunity to have an impact on disease.
Have we done I'm just curious, have we done a simulation on what it will be like to eradicate mosquito from our ecosystem?
So that's a really good question. And so our goal is not eradication. Our goal is elimination in a geographic area. Now, if somebody wanted to eliminate the mosquito, one could do that, but you'd have to actually work pretty hard. And so a couple things to keep in mind. One, Aedes aegypti is an invasive species pretty much everywhere in the world. So if we eliminated it from North and South America, that's fine. It originates in a part of Africa near Egypt, hence its name. So it's not going to impact. In fact, you're going back to a more natural ecosystem. The second thing to think about is that endangered species that might be eating the insects, right? We don't want to have an impact, even if they shouldn't be eating it because it's invasive. It still could have an impact. Well, Aedes aegypti is an urban mosquito. It loves to live around people. It can't survive on anything else. So it's not out in the forest. It's not around the water. It's going to be wherever people are. And so you don't have a lot of endangered species living inside people's homes, living in their backyards. And so because of that, you're also not likely to have that. Now, mosquitoes, Aedes only flies about 100 or 200 yards in its lifetime. So again, if you're protecting a particular area from the mosquito, you're just protecting that area, and they're not going to come back that quickly. So if you really wanted to eliminate it from a country, though, you'd have to have a countrywide elimination program, and you'd have to do it intentionally. Now, screwworm is an example of an insect that was entirely eliminated from North America using sterile insect approaches. That was using irradiation and not genetic engineering, but it has been demonstrated on a continent-wide scale to be effective. And so the only difference between what they did with mutagenesis and what we do is we don't need a gamma ray source.
And then is the process for taking away the Zika and dengue and the other disease, is it via genetic engineering? It's the male mosquito that's being engineered?
Well, so both the male and the female are engineered. We release male mosquitoes. Male mosquitoes don't bite, and so every mosquito that's ever bit you was a female. And so we introduced two genetic traits into it. One is that self-limiting trait, which is just a lethal trait, so when they go out into the wild and they mate, the offspring all die. Another one is a color marker gene, though, and what that does is it allows us to track and trace where our mosquitoes go. And so we really,
smart.
Yeah. So you think about it with insecticides, you go out and you spray, and then you go and collect mosquito eggs the next week, and the number goes down. Well, was that because you sprayed or because it was dry? the number goes up, does that mean you didn't do a good job, or does it mean the weather changed, right? So it's really hard to know whether or not we're being effective with no insecticide. But because we know how many we release, and we know the percentage that we collect, which ones are ours and which ones are not, we can actually estimate the number of mosquitoes that are in the environment and how good a job we're doing week to week. So we actually know, once we get more than 50% control in those traps, that we are on the way to eliminating the mosquitoes in that area. And so it's a really exciting tool that allows us to demonstrate the benefit of what we're doing. And in our trials, we've reduced by 90 to 99% the number of mosquitoes in an area. And we've achieved comparable numbers down in Brazil, where we're commercially releasing the product today. Yeah.
It's commercially releasing in Brazil?
Yeah.
Wow.
Yeah.
Okay, this is exciting. Okay, and then now, how about we do maybe a little bit of energy on our way to the food as well?
Yeah, so in Intrexon, actually our energy facility is in South San Francisco, so not too far from where we are right now. And there we're using methanotroph, which are bacteria that naturally consume methane, and we've engineered them to then produce different chemicals that are basically the constituents of gasoline and spandex and other high-value products. And so when you think about biofuels, you're often thinking of taking sugar and turning it into gasoline. Well, there you're taking a high energy form of carbon and you're turning it into a lower energy. We're taking a low energy form and we're turning it into a higher value product. And so we're also taking the cheapest form of carbon, methane, and turning it into a very valuable product. And so because of that, you actually get energy benefits from that. You have reduced greenhouse gas emissions from the fuel that you produce over what you would have with just a natural oil source. And so, it's just very exciting. And you think about this, the biofuels replacement market is an $80 billion market. And so, that alone is a huge market. And so we're excited about what we're able to do on that energy front as well.
So what is
Methanotroph?
Vanitros?
Methanotroph.
Methanotroph.
Yeah.
Methanotroph takes methane from the air.
Well, so they're the organisms that might naturally grow in a high methane area near vents and other things. And so what we're doing is we're engineering them to produce something. So they're already consuming methane as their source of food, but now we're engineering them to produce something with all of that methane.
With all the methane.
Yeah.
So interesting what tapping into DNA can do.
Yeah.
Wow.
Absolutely.
And widespread across all these different fields.
Well, and so if you think about it, if we could reduce the carbon footprint of the fuel that we produce by 5 or 10 or 15% and drive exactly the same that we are today, that's a pretty dramatic impact. When you talk about changing fuel mileage, you're going to get a few percentage increase, but you've got to produce millions of cars in order to do that. Here you're using exactly the same infrastructure we already have.
Okay, so these are really good foundational pillars of what you guys are working on, and now this massive one, which is food.
Yeah.
Sustainably, nutritiously feeding Earth by 2050, and through amazing things like these Arctic apples. Let's unpack this and where it's all going. You were just having an Impossible Burger too, just a little bit ago.
Just visiting their facilities and giving it a try for the first time. So I'm really excited about what we're doing in food and ag. I come from an ag background, working at the U.S. Department of State in food policy. And there are so many things. I mean, one is that one of our subsidiaries is Transova Genetics, which is one of the largest livestock genetics companies in the United States. And every day they're improving the genetics of those animals, but they're also thinking about how do we not just improve a little bit every year, but how do we really expand that? So think about livestock genetics today. What they do, as you probably know, there's artificial insemination. They get the semen from the bull and they go out and they use that. Well, that's like...
It's brutal. Yeah. It's brutal. I mean, it's cow and birth, and then cow and birth, and...
Well, there is a lot going on there.
And stripping it away from the mother.
But with the semen, they're going out there and collecting it, and in the semen straws.
Getting that.
Well, but think about this. If this is like a farmer goes into the seed shop, and instead of buying seed, he can only buy pollen. That's what artificial insemination is. We're getting half the genetic potential, and so our genetic gain is half as fast as it is with plants, because we're only using the semen from the bull. And so part of our thing is, well, how do we bring the genetics of the female and the male so that we can double the speed at which we improve animal genetics?
Yeah.
And so those are some of the things that we're thinking about, is, not just how to improve it, incrementally, which we are, but how to accelerate that. And because of the challenges we have, it's important.
And I want to say that this is an important thing to say, because I think a lot of people think like, oh, is this ethical? We've been doing genetic engineering forever with our food. We've been figuring out how to maximally gain yields from our crops that we plant. We've been figuring out breeding. We find partners that we think have a high intelligence or high attraction, and then we breed with them. So we've been doing these genetic engineerings forever. So it's not, this isn't anything new or different, but it is.
It's an extension, right, of what we've been doing. So, people are all familiar with corn, but of course, if we were to look at teosinte, the progenitor of corn, it's a little weed about this big, and it's not very fun because, it's got these hard shells. And so through just conventional breeding and selecting different varieties, we have turned that into an ear of corn, which is like this, and which is a hybrid. And so yeah, I mean, it's amazing what's been done just through conventional breeding, and what the potential is. Because the problems are so big, we need a really big tool set. So one of the things that you mentioned, though, was the Arctic apple, and that's produced by our subsidiary Okanagan Specialty Fruits. And for me, this is the most exciting GMO in the world, because this is the first GMO that people will buy because it's a GMO rather than in spite of the fact.
Yeah.
Right? So for me, they're buying it because of the science.
Yep.
It's like, this does something that benefits me as a consumer. But what's exciting about it as well is that every person who touches that apple in the supply chain benefits. If you're a grower, less finger bruising. If you're a shipper, less loss. If you're a retailer, less loss. And then the consumer, of course, the kids eat it and don't throw it away at the end of the day.
Yep.
And what people sometimes don't recognize is that apples are the third most wasted food item in America. Bread, potatoes, apples. So this is not a small part of the problem. This is a big part of the problem.
Yeah.
And so sometimes people will say, well, I eat the brown apples. My response is, well, when was the last time you went to the grocery store and you picked a brown apple to take home? Yeah. Because at the end of the day, those are all going to get thrown away.
Yeah.
Unless they're Arctic apples, and then tomorrow they're going to look just fine too.
And so what is the engineering process for removing the browning enzyme?
So there we're just using RNA interference. We're just turning it off by binding with another piece of RNA. There are other ways you could do it using knockouts and gene editing and things like that. But our technology, we developed this, a decade ago, and so before CRISPR and other things came along. But all we're really doing is we're turning off the enzyme that produces polyphenol oxidase, which is the enzyme that causes browning. And sometimes people say, well, is browning important? And it's only important if the seed is going to rot and then grow into a tree. But nobody grows apple trees from apple seeds, because we don't know what pollinated them, right? So we don't know what tree it would grow into. So pretty much all trees, whatever variety they are grown from cuttings from another tree. So they're all clones of each other anyway. And so nobody's growing it from a seed, so we don't need any of these apples to rot. And so rotting has no value for people. It just increases food waste, and we lose so much of it, 40%.
And now it takes, rather than like a day or even a couple hours to brown, now how long does it last for?
Well, it's not going to brown.
Even in like 2 weeks?
It's not going to brown. Yeah, so now it's going to dry out, and it's not going to be as
tasty,
nice, and so there are things about it that you might not like as much, but the apple itself is not going to turn brown. Now, right now on Amazon, you can go and you can buy our app bits, which are dried apples, and the nice thing about those, you don't need any preservatives, because we don't have that problem with browning.
Yeah.
And so and we can do that with the apples that are a little too big or too small, that aren't right for selling as sliced apples. We can still turn them into a high value product.
Awesome. And now this is extending because you said it by most wasted food in the U.S. it's bread, potato, apple. So
Yep.
that's huge. We're right up there in the top most wasted food. So that's already come in. Hopefully we can do something about bread and potato.
Well, potato there already is too. So Simplot has developed a non-browning potato, which is on the market as well. Yeah.
Non-browning potato. Potatoes are, I mean, they last pretty long, but
They
Yeah.
do, but that still causes a significant amount of the waste with potatoes. And when you put them in cold storage, then those can become black spots, and then people end up cutting them out. And instead, they won't have that, and so it'll last longer. You'll have a better, higher quality product.
And then, okay, so now we did apple, we did potato, but you guys are also doing, I saw avocado and pear and lettuce.
Yeah. So we've got other products that are in the pipeline. And so, people sometimes ask, why did Intrexon buy an apple company? And the answer is, we didn't. We bought the ability to transform every fruit and vegetable in the world.
Yes.
We're going to demonstrate consumer acceptance, that we can deliver a product that people want and love, but then all of these other products can come along. And so it's a platform. The apple is a platform, just like biotechnology is a platform.
Yes.
Yeah.
And then what else are you working on in the future food? What else are you super excited about? Actually, you guys are in aquaculture too, right?
Yeah, so one of our majority-owned subsidiary is Aqua Bounty, and that's the salmon that reaches normal size in half the time. And this is exciting because when you think about feeding the world, we need to double food production by the year 2050. Well, if we replaced all of the farmed Atlantic salmon being produced today with Aqua Bounty salmon, we would double production tomorrow.
And how does your technology work?
So what we've done is we've introduced a gene that is a growth promoter, and the Atlantic salmon only grows part of the year. And so by adding that promoter, it grows all year round, just like a Pacific salmon. And so it reaches normal size in less time, but importantly on less feed as well.
Yeah,
so
less
50
feed.
or 20%.
Huh.
So think about that. If you're getting twice as much food and 20% less feed, that's pretty significant. And when you think about the fact that 80 or 90% of all the agricultural land in America is for food crops for animals, not for people,
That's crazy.
you begin to understand the impact of animal feed on our food system.
And it's so strange to me why there's more and more technology. One of our friends working on where it just a nice little fence just moves along 1 foot every couple of hours, a couple of days, and just they can move the animals right on the grass pasture, and the animals will just move and continue eating the grass, and then they're completely grass fed. And it just, these things make more sense than growing all of this corn and soy and then pumping that into animal feed.
Well, there's a time and a place for grass-fed, but we couldn't produce as many animals as we do today if we tried to do it all grass-fed.
1 million chickens per hour in the U.S.
Yeah, so that's there are about 9 billion animals that are produced in order to feed 7 billion people. So per year.
9 billion animals.
Right.
For 7 billion humans, 7.5 billion humans.
Yeah.
Oh my God, per year just slaughtered.
So the numbers are great, but if you look at how much more productive each of those animals is today than it was 30 or 40 years ago, you need 3 times as many animals if they were just as productive as they had been.
That's right.
So there's this tendency to look at agriculture as it is today instead of where we've come from.
Yep.
So it's absolutely true that there is nothing we do that has a bigger, more negative impact on the planet than agriculture, but there's nothing more critical for our daily survival. And so when you think about how much water does it take to produce a kilogram of beef? 10 to 15,000 liters of water. That's a lot of water when you think about all that goes into the feeding and to the grains and other things. But if
it's grass-fed, less.
Yeah, well, but in 1980 it took 20 to 30,000 liters of water.
Less efficient over
50% less water to produce that kilogram. So things are much better than they were, but we have this tendency just to look at eutrophication of waterways and all of those problems, and those are all real problems. But there's a big difference between things are bad and could be getting worse than things are better but need to get better even faster.
I really like that perspective. I think we frequently lack that perspective, Jack. I mean, that's probably one of the most interesting things that you just highlighted, is that when we look at where we are today, one of the things we have to understand is where we came from and how much hard work and engineering that we did in order to make things more effective and more efficient and decrease suffering and increase amount of food and prosperity. And then where are we going in the future, and how do we engineer a better world tomorrow? I love that understanding.
Yeah, and so when you think about it, if you look at agriculture as a problem to be solved, then farmers are the problem. But if you look at where we've come from and where we're going, they're the solution to the problem. And I think we need farmers to be part of the solution, not the problem. And so, we really need to change that mindset. In some ways, consumers have never cared more nor known less how their food is produced. And they care a lot about it, but they don't have a good connection to it anymore because more and more of us live in cities, right?
Yeah.
We don't spend time out in rural places. Yeah. If you ask people, how much do you think you know about how food is produced? People in cities tend to report higher knowledge than people in rural communities. Might not be true.
The Dunning-Kruger effect.
Yeah.
That's so funny. That's a great example of Dunning-Kruger, actually. In the cities, they think they know more, and then in the rural, they're like, we know a lot, but we know nothing.
Right.
That's so funny.
Yeah.
Wow. Yeah. Okay, so continue us on this trajectory where we're heading with future food.
Yeah. So we need between 70 and 100% more food by 2050 because we're going to have 9.5, maybe 10 billion people on the planet. And people are rightly concerned about how we're going to sustainably feed those people. But let me give you a different suggestion. Now, imagine for a moment that our productivity increased fast enough that we did sustainably feed those people so that we don't need to cut down our forests and drain our rivers, lakes, and aquifers. Okay, so we've got this trajectory going up and population going up. But what happens to population growth after 2050?
Oh, flatlines.
It flatlines,
Yeah.
right?
Population stabilization because of developed nations and equal birth rate. Yeah.
Right. So for the first time in human history after 2050, we won't need more food. Mm-hmm. So if productivity continued, though, on that line, for the first time in human history, we could take all of that productivity gains and start to reduce the footprint of agriculture. So by the year 2100, we could either produce everything organically, or we could take all of South America out of production. We have choices in a way that we don't today. And so one of the things that I like to tell people is that the next 35 years are not just the most important 35 years there have ever been in the history of agriculture, and they're the most important 35 years there will ever be in the history of agriculture. If we get it right, we're good forever.
Yeah.
And so for me, that's really a message of hope, but it tells us now is really, really important. And these decisions that we're making are critical to the survival of the planet.
You are so right about that. And it's so interesting that we were just talking about the importance of these next couple of decades in terms of artificial intelligence as well. But we got to figure our shit out so that we get past these next couple of decades successfully. And the same thing's true about agriculture and feeding our planet. These next couple of decades, most important. So it's interesting how exponential technologies are impacting the way that we live and the way that we're about to be living.
Well, one thing that I think, for me, changes how I think about all of this is if you think about the year 2300, and I ask people, how many people do you think are going to be on the planet in 2300 if we have 11 billion people on the planet in 2100? And they say 11, 12, 15 billion people.
9 maybe, yeah.
3.5. That's the current estimates.
Because we will continue having only one offspring per couple, and
Yep. So if the rest of the world followed Germany's example of 1.75 children per person, there would be nobody on the planet in 2300 if we adopted that.
Is that right?
Yeah. Well, where are they going to come from? Once you get below
Even
replacement.
Even at just 1.5, it'll be out by 2300?
Well, because you need over 2 to account for people that die, so you need like 2.1.
To account for people that just die.
Right.
Oh, yeah.
So you need like 2.1, 2.2 is replacement. So they're way below replacement rate. And so, you look at Germany, you look at Japan, you look at Italy, you look at all of Europe, and if it weren't
And the
for
US
immigration,
as well now.
and without immigration,
Yeah.
all of these countries would be, shrinking.
Look at the
fast,
millennials and the Gen
right?
Zers. I mean, they're not having offspring until
Right.
they're 35. They're waiting as long as possible, and even then, you're having one kid at most. And
Right.
they like option, they like choice, and also, your kids now, like they're like, I'm gonna live until I'm 100. I don't need to have kids when I'm 25. I can wait until I'm 40. Freezing sperm and eggs, and gestation now happening outside of the womb. There's all these genetic engineering,
Right.
disease. I mean, this is such an interesting topic about population stabilization and even
Right.
decline. Yeah.
Well, and the Swedish statistician Hans Rosling, who died, what he said was the year 2014 was the year of peak child. The number of children born in 2014 was the most children that will ever be born in a given year throughout human history. It's
Damn.
downhill already. So what year do you think the rate of population growth peaked? What year would you guess was the year at which it peaked? Not the number of people, but just how fast it was growing.
Well, I know that we went up by 1 billion people about every 10 years recently.
Yep,
That was-
12, right? But that's not the rate. So the fastest rate of growth was in 1966. So every year since 1966, the population has grown, but it's growing at a slower and slower rate. And so, this isn't like, hypothetical, yes, maybe things will start to decline. We've got 60 years of really good evidence that population rate of growth is on the decline everywhere in the world. In the developing world, sure, they're having 7 or 8 kids, but even today, it's only about 2.5 is the number of average for the whole planet.
And once the developing world becomes developed.
Right.
Yep.
And so the global total fertility is about 2.5 today, and in 1950 though it was 5. And so things have changed dramatically. So now there are just a couple of countries in the world that are going to drive population growth into the future. Countries like Ethiopia and Nigeria.
Yeah. So let's. This is really important that we talked about population demography. We don't talk about that enough. So, now take us through, because there's a couple of these exploding industries. I mentor at IndieBio, and so I get to talk a lot to all these different biotech companies that are especially doing things like growing. Using stem cells to grow meat instead of slaughtering animals. So we're doing things like taking this stem cell from a chicken, taking it from a cow, taking it from a pig, taking it from fish, and just growing. And soon the idea is to have these massive just breweries and brew the meat in just bioreactors. So where is that going? Eggs and yeah.
So you have sort of these two protein trends. You have the plant-based foods, where the Impossible Foods and Beyond Burger and others that are working on that. But then you have companies like Memphis Meats and Finless with seafood, and others, Perfect Day on the milk that you're talking about. And so there are different approaches to this challenge. And so using cells to brew them in a bioreactor and then provide a substrate in order to a scaffold to then produce that product, is something that's coming along. There's still a lot of work to do. There's some technical hurdles that have to get over, but that's likely to be part of the solution. Whether it's in the next 5 years, it's harder to say, but 10 years from now, 20 years from now,
indistinguishable taste.
Well, we'll have to see. It's one thing to produce a hamburger or a meatball. It's another to produce a ribeye and a T-bone and filet mignon and all of those different types. And then you have all the different breeds of animals that are out there. So that's all challenging. But why does cell-based meat have to follow the path? Right? It could strike its own.
We could design new things.
Yeah. So they're trying to do that today because that's what people wanted in the past. But who knows what people are going to be open to in the future.
Hashtag new meat.
Right. Well, you know, the sector has sort of looked at the term clean meat.
Yep.
And, you know, I think that there are some challenges with that term because I think it suggests either food safety, you know, it's safer, and when you talk about safety, people just think unsafe, they don't think safe, or it suggests a moral and ethical aspect to the conversation. And for me, that's unnecessary. When somebody wants to eat a hamburger, they really don't want to have a debate over the morality of animals. And so I threw out there the concept of craft meat as an alternative. So craft meat, cell-based food. And the reason for that is not so much that you adopt that specific term, but when you go in and you try to talk about your product. If you talk about clean meat, you immediately get into a conversation about morality or safety.
Yeah.
If you talk about craft, you can talk about quality products, brewing, place, right?
Artisanal work.
The thing that comes to mind when you think of craft is that there is a place where it was produced and humans made it.
Yeah.
Right? So as soon as you say Memphis meets San Francisco, it's like, oh, I want to go there. You know, it's not a package, it's a place that produced that product. And so I think what Impossible Foods and all of these others is that they need to be able to connect their food products to a place, because a lot of where the public is going is wanting to know the provenance of the food they eat. So this is something referred to as conspicuous production. You know, in the past, we wanted conspicuous production. We wanted to be able to buy things other people couldn't have. But today, we want to know where things came from. We want our purchases to be a reflection of our values.
Yeah.
Whether it's environmental or ethical or animal welfare.
Yep. And that's the craft food. I like that. Craft meat, craft culture, craft everything. It's like you want to know what farm you got your food from. You want to be able to say that, hey, my virtue, my value, this is what I believe in. And then you're right that it kind of strips away from the morality conversation. It's more about, hey, that location does it this way. This is what I value. Interesting, Jack.
And we don't have to pit the new food industries against the old food industries, because we need twice as much food. So Impossible Foods and all plant-based and cell-based could grow to be just as large as the current food system, and the other ones could still do exactly what they do today, because we need twice as much.
And then consumers will make their decisions with what they want, and then one of them could end up thriving.
Yeah, so maybe one wins out in the marketplace, but you know, we've got 50 years before we need to worry about whether or not that's going to happen, because we still need so much more today.
Yep. So other thoughts about future food that you think are really important to highlight?
Well, the question for me is not the science. I am totally convinced that science and technology can get us where we need to be. I'm a science optimist.
Yes.
But I am a regulatory pessimist. I'm not at all sure that regulators will allow us to go there. So what was just decided today in Europe was that European regulators will regulate gene-edited products exactly like GMOs. So unlike the United States, where USDA has indicated that they're not going to need to regulate these in plants because the types of mutation or edits you can produce are similar to ones that could have occurred naturally, that means that every little product that you try to produce in Europe needs to go through a GMO regulatory process, or they have to figure out what that process is going to be. But in theory, they are regulated as GMOs, and so there's a reason why we don't have every apple and carrot and tomato and other things genetically engineered today. It's just there's not a big enough market to spend $100 million to bring it to market. On the other hand, if you could just go in and do a simple gene edit and produce a non-browning lettuce, and then you could go through, for a couple $1 million, get through regulatory review and have the product on the market, you can imagine doing, romaine and all these different types of lettuce. But who's going to spend $100 million to bring every type to market? So there's a real challenge to that regulatory. The other challenge, though, is that our food system is fighting itself, fighting amongst itself. And for me, if everybody would just focus on solving their own problem and producing their own product and let the other guy produce their product, if it's a better product,
They'll
figure it out.
Yeah.
If it's better for the farmer to grow it in this way, then eventually farmers will figure it out. They're pretty smart.
Yep.
Yeah.
That's a really important key that you mentioned, regulation, because there's got to be the right sort of amount of regulation to have the right amount of safety for people, longitudinal testing, all this isolating variables, all this kind of stuff, but also let innovators innovate.
Yeah.
And if we impede innovation, we fall behind in terms of around the world, the places that want to innovate.
Yeah.
So I'm glad that you brought that up. Okay, this has been super enriching. Let's ask you a couple questions on the way out that we usually ask our guests. Jack, do you think we are alone in the cosmos?
Statistically, I suspect we are not. No, I feel pretty confident there are other people out there.
Yeah, and to you, what does that look like?
Well, I suspect that I think less about that than I do about simulation.
Okay.
For me, that's the nearer term. Because if somebody was going to show up and introduce them to us, I suspect they would have done so by now. But I think that the questions around computers and virtual realities and other things like that, that's a nearer term question that we're going to have to grapple with as humans.
Well, then let's ask you, do you think we are in a simulation?
Statistically, we must be.
Yeah.
So because at the rate we're going, it seems inevitable that we won't reach a point at which it's impossible to determine whether or not we're in a simulation.
Yeah.
And once we reach that moment, it's certain that tens or hundreds or thousands or millions of virtual worlds will be created.
Yeah.
Well, if you've got tens of millions of virtual worlds which are indistinguishable from the real one, what are the odds that we're in the real one?
Yeah.
That there is a real one.
Mm-hmm.
But I think that that question is interesting, but what's interesting for me is its implications for what happens to humanity in the next 50 years when we reach a point where people might be able to log out of the real world because maybe they're too old, but stay for decades in a virtual world.
Exactly.
And will they choose to engage with the real world and continue to be a lawyer and make money in order to be able to buy more virtual cars? Or will they just spend the rest of their life there? I think that that's one part, and then I imagine another part of humanity will choose not to do those things. But because of science and technology allows them to lead healthier lives, it's not as if they're going back to the way things were 1,000 years ago. They'll have a very different engagement with nature because there will be fewer and fewer people around. Nature will become wilder and wilder after 2050. Right?
Sounds great.
Today, forests are growing in every developed country in the world. Forests are expanding.
Yeah.
There are only 2 countries in the world that are driving global deforestation. You've got Brazil and Indonesia. Right?
Interesting.
Soybeans and palm oil, 2 products.
Interesting.
And so, to me, once we reach that inflection point, there's this opportunity for the rewilding. We don't have to try; it's just going to happen.
That's so great. That's such an optimistic idea. I love that one. Because as population decreases, nature will also increase, and we're doing things like there was 1 billion trees planted in Kazakhstan, and also things like you just mentioned about simulation theory. It's about the expansion of awareness to these dimensions of thinking, and when we do manifest our own simulation and we see ourselves, then what do we think? What do we learn? Which one do you want to live in? Tap in, tap out. They're indistinguishable. I'm glad that you've went into these deep thoughts about it.
Oh, fascinating topics.
All right, last question is, what do you think is the most beautiful thing in the world?
Oh, for me, it's connections to people. So that's the best part of life, is getting up and seeing the people around you and getting to interact with them every day.
I love that one. Yeah, and you got some family, you got some friends, you got some coworkers, you got some, romantic relationships, you got your business relationships. It's people that you're building the world future with. Yeah.
Well, because if you're passionate, you need to share that passion. You know, it's very hard to be passionate alone.
Yes. Love it, Jack. Very insightful. Thanks for teaching us so much about future of food and about biotechnology. This has been an absolute blast. Thanks for coming on to the show.
Thank you.
This has been super fun and really educational. So homies, people that have been watching, if you guys had a good time, definitely go and share with 2 other people. Go and share some of the knowledge that you've been learning. Also, join us, subscribe, comment below. Would love to hear your thoughts. Let's build community around future food and biotech. Also, join us on Patreon. Help us support this, help us grow it, impact more people. Thanks everyone for tuning in. Thanks Eddie for filling in, our producer director for the show. Much appreciated. Thanks everybody. Much love. Peace. Awesome.
All right.